Hi everyone, welcome to the second block of the awesome Matchmove artist course. Let's start this video by talking about how auto-tracking works. The very first thing we need to do is load the shot and set up the camera and lens parameters. This is always the first step in any new project. We select an already created empty sequence and, in its properties, click Browse. As always, all my files are under NDA. We choose the folder, select the sequence and click OK. If you're using a gamma of 2.2, like I am here, make sure to set that right away in the sequence settings under the 8-bit color correction section. I'm also going to adjust the soft clip so I can better see what's happening in the highlights. This is anamorphic footage, so it might look a bit strange at first. It's slightly squeezed. I briefly mentioned this in the first lesson. Anamorphic lenses differ from standard ones in that they basically compress the image horizontally and record it onto the sensor like that. This allows the camera sensor to be fully used, and later the image can be stretched back to its correct proportions. Visually, our eyes don't really notice this stretching once it's done, but when working with anamorphic material, we must load it in its original squeezed state and only unsqueeze it inside the software. Of course, if someone has already unsqueezed it for you, you can still track it. But just know, blame whoever did that. You need to work with the original source material, and the same goes for when someone asks you to track using a JPEG, or if you're thinking of doing that yourself. You really should be tracking using uncompressed images. JPEG is compressed, and that compression affects quality. If you know that JPEG compresses in blocks, those compression artifacts are exactly what you'll end up tracking, especially considering that JPEG has lower color depth compared to formats like EXR or DPX. It's only 8-bit. Track using source files, track using the unsqueezed anamorphic material. Now let's move on to lens settings. So we already know the camera sensor height and focal length. The sensor height is 17.85 millimeters and the focal length is 50 millimeters. Since this is anamorphic footage, the pixel aspect ratio is 2. That means the pixel ratio is not 1:1, that's 2:1. And what you're seeing now, this is the image in its correct proportions. Even if it might not seem that way at first, your eyes are just used to the squeezed look, and this may feel like an overcorrection, but it's not. Let your eyes adjust. This is the original image. Now, let me save the project, just in case anything goes wrong. The loaded sequence can immediately be cached so that playback is smooth. If we press spacebar right now, we'll see that the sequence plays slowly because each frame is being read from disk. What do? We go to the playback menu and select Export Buffer Compression File. That's the cache, I've already talked about it. Great, and now we can play back the sequence by pressing the spacebar. And it plays back fairly quickly. This shot was kindly provided for the course by the studio Algus. These are frames from the film T-34. Under the terms of use, you may study this shot and review it, but you are not allowed to share, publish, or use it anywhere else, including in your personal showreels. This shot is not for public use. However, once you've learned how to Matchmove, you're welcome to contact the Algus studio and say, "Hi, I've completed the training. Are you currently looking for Matchmove artists?" Thanks again to Algus Studio for providing the material. So right now we've got a sequence loaded, and we're basically ready to start working. Let's take a look at how auto-tracking works. Usually auto-tracking is just a single button like in After Effects or something like Nuke, where there's a button with a few options that essentially says, "Track it, give me a camera." You press it, wait a bit while it processes, and get something as the output. But why is that good? Why is it bad? And what's actually going on under the hood? In reality, it's pretty simple. Auto-tracking is not some magical process where you press a button and the camera gets magically tracked. It's essentially a heavily simplified, automated version of the manual tracking process, and that's exactly what this course is all about. Here's what actually happens when you run auto-tracking, so you don't think it's some kind of black box that replaces manual tracking. It performs a 2D track, frame by frame, looking for high contrast areas and tracking them. Then it tries to match the camera parameters you provided. If you've set a specific camera, like in Nuke, it will use those settings. It may try to estimate distortion, but only if that's enabled. If distortion is not enabled, it skips that step. Then it calculates the camera movement based on the tracked features. At the same time, it roughly estimates the 3D positions of the features. Why is this bad? Because you hardly have any control over the process. And the more control you try to add, the less auto it becomes. In the end, it's usually easier and better to just do it manually. Auto-track can be useful in very limited cases. For example, drone flyover shots, where nothing gets in the way and the movement is smooth. Situations where you just need to hit a button, set camera parameters, and go. Motion graphics shots where you don't need precision, scale, geometry, etc. Even if all you want is to stick graphics to a building, you'll often notice issues at the edges distortion isn't accounted for, and the graphics drift. In Nuke, auto-tracking is fairly customizable, but if you want high quality results, it's much better to do the tracking in 3DEqualizer, where you have full control over every step. So once again, why auto-track is bad? Because you don't control anything. Why auto-track is good? Because you don't have to control anything. Now let's take a look at the actual settings. Go to the camera settings and head over to the auto-tracking settings section. What are these settings? These are the settings for the automatic 2D tracking system called 2D Feature A. In theory, you can leave everything here as is and it will still work, but let's take a closer look at what these settings actually mean and how this system works. To activate auto-tracking mode, go to the viewer panel and switch it to auto-tracking mode from the drop-down menu. I'm already in that mode now. In the program itself, you can press F4. If it says auto-tracking, that means you are currently in auto-tracking mode. And here's the actual auto button. Once you click it, the program will ask whether to track forward only forward and backward, or backward first, then forward, or even to skip one of the passes. Then you click track, but let's stop it right away because in this case, we don't want to track the car. Since it's moving, we only want to track stationary objects, so I'll hit the stop button. But this is just an illustration of how auto-tracking works. In any case, it tracks 2D points, and then those are used to solve for the camera. Alright, let's at least clean this up properly. I'm opening the point browser, holding shift to select all the points and deleting them, because this isn't what we need right now. Only the tracked points are selected, not the camera, of course. We don't want to delete that, just the points. And we delete them. Let's now tweak the 2D feature tracking process in auto-tracking. We go to the camera settings, technically the sequence settings, but here it's labeled as camera. Then we scroll to the auto-tracking settings block. In general, even if you don't change anything in this section, everything will still work. The program will track 2D points automatically. These are the settings for tracking 2D features only. And since we're still early in the process, I'll keep repeating some foundational things. Tracking is divided into several stages. And one of the most important stages is the initial 2D tracking, getting those tracked 2D features that everything else will be calculated from. So these are the settings for generating 2D trackers. They determine how trackers will be created when we press the auto button in the auto tracking viewer mode. Active points per framing. This defines how many tracking points will be automatically created, meaning how many contrasty features will be detected and used. The number is typically in the range of 30 to 60 points. When should you adjust this parameter? Let's say you start auto-tracking and you've masked out some area that should not be tracked. In the area where tracking is allowed, you might find that the trackers are placed too densely. I know too densely sounds vague, but for example, if you're getting 5 points within just 10 pixels, then it's a sign that you should reduce the number of trackers. Adjust active points per framing downward in those cases to prevent overcrowding of points. In general, tracking points should be spread across different planes and depths. This means your trackers should be distributed evenly, some closer to the camera, some in the midground, and some in the background. The more depth layers are involved, the better and more accurate the result will be. This applies to both manual and automatic tracking. You can control the number of trackers in the auto-tracking settings. For example, when we just ran the auto-tracking earlier, we saw that the program locked onto the car because it's the most contrasty object in the frame, but the program doesn't know the car is moving and that we shouldn't track it, so it happily creates tracking points on it unless we guide it otherwise. Minimum length is a parameter that defines how many frames a tracker needs to survive for the program to consider it reliable. By default, it's set to 10 frames. If a tracker lasts fewer frames, it gets deleted. How to work with it? Lower the value when there's fast motion in the shot and objects don't stay on screen for long. If no object stays visible for at least 10 frames, AutoTrack won't find anything, all trackers will be removed. Increase the value when the camera moves slowly and smoothly like in drone flyovers. In such cases, it's better to have fewer trackers, but ones that last longer. This gives more reliable results than constantly generating new ones. Search interval defines how often the program looks for new tracking points. For example, if it's set to 15, the software will search for new trackers every 15 frames. You can actually observe this in action by pressing the track button. While the points are red, it means the tracker has just been created and hasn't yet reached the minimum lifetime threshold. Once the points turn yellow, it indicates that the tracker has remained visible in the frame long enough, for example, 10 frames, and is now considered reliable. These yellow points stay in the tracking process. Red points are temporary, they may still be deleted if they don't meet the minimum lifetime. Alright, I'll cancel the tracking for now, since everything is still not working properly at this stage. And I'll delete them again. Well, I think it's clear now. Just based on this color indication red and yellow, you can roughly understand what you're working with. whether you need to increase the minimum track duration, whether you need to search for new trackers more frequently. Again, it all depends on the dynamics of the shot, how fast objects move, how stable the camera is, and how long features remain visible in the frame. Search area size and pattern size are sizes given in percentages, with the equivalent in pixels shown in parentheses. Pattern size refers to the size of the actual pattern being tracked. Search area size is the region where the software looks for that pattern in the next frame. We'll come back to this a bit later, it will make more sense once we see it in action. Minimum distance, also in percentages and pixels, defines the minimum spacing between detected tracking points essentially. How close two trackers can be while still being considered separate. Right now we saw that all the trackers got concentrated on the truck. All 30 to 60 of our trackers ended up in the same small region of the frame, which isn't ideal because the truck is not something we want to track. A better result would be to have the trackers evenly distributed across the frame. If you increase the minimum distance value, the software will still try to place the same number of trackers, but it will spread them out more, avoiding clustering too many points in a single area. I'll click Auto. Alright, we don't want to track the sky either, but we'll deal with that in a moment. At least now the software is looking for trackers in other areas as well, which is overall definitely a better result. Let's click Stop and take a look at what else we can adjust. Delete again. What next? Tracking sensitivity is, roughly speaking, how picky the tracker is. The higher the sensitivity, the more quickly the tracker will break when there's even a slight deviation. A lower sensitivity means the tracker will keep going even if there's a visible error. It kind of tolerates the drift. Compensate brightness is an option that tries to account for changes in image brightness. For example, if the lighting in the scene shifts slightly, the tracker will attempt to adjust for that. But it's important to understand that in the case of abrupt lighting changes like a flash, a strong flare, or a sudden shadow sweep, the auto-track will almost always fail, and only manual tracking can save the situation. You can compensate for minor brightness fluctuations by enabling the Compensate Luminance Changes checkbox. So, what's the next step? We need to create a mask for the truck. This is done directly in the viewer, specifically in auto-tracking mode, because if we were in a different mode, the masking tools would be unavailable. Each viewer mode in 3DE has its own set of tools and functionality. If you're working with auto-tracking and need to use masks, make sure you're in auto-tracking viewer mode. To create a mask, simply click Add Mask. Then we move the mask points as needed. You can add new vertices using Control. Hold down Control and left click on the mask spline. To select a single vertex on the mask, simply left click on it. If you want to select multiple vertices, and this applies to most selection actions in Equalizer, use Alt plus left click and drag, or use Alt plus Control to manually lasso select points. If you don't want to deal with Bezier curves, you can switch the vertex mode. Go to Edit, Toggle CV Linear Spline State. The mask is also animated using keyframes. If you select the mask, you'll see a red frame indicator that means it's a keyframe. You can move to another point in the shot, adjust the mask there, and a new keyframe will automatically be created. Dragging the entire mask, I select it using Alt and hold Shift to move everything. But honestly, working with masks here is extremely inconvenient. Overall, just a heads up. Alright, let's take a look at what we've got so far. Everything that appears light is eligible for tracking. Everything dark means don't track this. Alright, I'll revert the minimum distance setting. Lowering it will help prevent the tracker from trying to grab the sky due to lack of available points. Now, let's run the track again. There are two passes forward and backward, because during the forward pass, you might catch some trackers that are just entering the frame, while in the backward pass, you might catch others that are exiting. This is especially relevant in areas that frequently enter or exit the visible frame. That's why tracking is done in two passes to capture all possible points that appear and disappear throughout the shot. Also, if we don't want to track the entire shot, we can set a specific frame range for auto-tracking. In that case, the track within frame range only checkbox becomes active, and we can enable it. But for now, we're tracking everything, nothing to lose. And now we can see how points begin to appear on the snow, while there are no points on the vehicle as expected. And now the backward pass. So now we have our 2D trackers. Let's go over what we've got. We can see that the trackers avoid the truck and are more or less evenly distributed across the scene. Nothing is landing on the sky area, or if anything does, that's a bad sign. It means the software is struggling to find usable detail and is resorting to a mostly flat, low contrast region. So the issue isn't the sky itself, it's that there's simply nothing there to track. If there were clouds or any sort of texture, it wouldn't be a problem. It all comes down to having enough high contrast features for the tracker to lock onto. There's a setting called Auto-Tracking Mask. You can disable the mask, enable it again, or invert it, which is useful when it's easier to define what you do want to track instead of what you don't. That happens quite often. You can also import your own mask created in another program. So right away, it becomes clear 3DEqualizer is not meant for working with masks or doing any kind of rotoscoping. If you've already created a mask in Nuke, Mocha or anywhere else, you can render out a Luma-based mask sequence and load it here. Let's take a look at how that works. A Luma mask is a black and white image where the pixel brightness of 0 means unmasked, allowed for tracking, and brightness of 1 means masked, excluded from tracking. Visually, it looks like a regular grayscale image. In this case, it's okay to use JPEG files, since smooth gradients aren't critical here. To use it, enable Image Mask. Specify the path to the image sequence. Here I have the mask applied to the car. We need to check the invert option because we're tracking the bright area and telling the software not to track the dark one. So we invert the mask. There's very little contrast in the snow, and naturally, tracking a low contrast image is difficult both for us and for the software. Let's see how we can tweak the image a bit. From the Windows menu, open the image control window. This is what it looks like. It's a panel that allows us to tweak how the image is displayed purely for convenience during tracking. How is it different from the 8-bit color conversion settings we used when loading the sequence? Those define how the image should correctly look in terms of color and gamma. This panel, on the other hand, is just for visual aid to make the image more convenient to work with, especially during certain tracking stages. The panel is split into several sections, and the top section is just a master toggle. It enables or disables the entire panel. To the right, there are preset buttons that let you switch between saved adjustment configurations and a reset button to revert all changes. When you enable the panel, you also need to specify which block you want to activate. For example, there's a chroma key block. It allows you to push the image in a way that reveals contrast-rich areas that are easier to track. There's also a curves block, a traditional curve editor which gives you fine control over the tonal range of the image. You can also create a new control point on the curve by holding Control and clicking. This allows you to adjust the image's gamma visually. The entire panel or any individual section can be toggled on and off as needed. The next block is color controls activated as well. Here you'll find gamma individual brightness, controls for red, green and blue channels, overall brightness, contrast and saturation. And the next block is blur. Here you can either slightly blur the image or conversely sharpen it. In this particular case, we probably don't need it. All of these blocks can be toggled either using the main enable button or via the keyboard shortcut, the letter I. Just switch back to the main viewer window and press I, the panel will turn on or off. And with these settings in place, we can now run the auto track again. The passes are done. Now we have our 2D trackers created. Camera parameters are set in general. We're ready to calculate. The camera is calculated as follows. Go to the Calc menu and choose Calc All from Scratch. This means calculate everything from scratch. If you're not yet very familiar with 3DEqualizer and you're wondering why your results reset every time you make changes after calculating, pay attention to the name of this command, Calc All from Scratch. It completely recalculates the scene from the beginning. Every time you use this command, the results of previous calculations are discarded. Only the original data remains. Your 2D trackers, their settings, camera parameters, measurements, etc., but not the data produced by previous solves. Click it or use the shortcut Alt+C. This window pops up and yeah, not great. So what does it mean? Green dots, these are the calculated positions of your 2D trackers in 3D space. Red dots, the camera's motion path. White line, the camera's view direction. White vertical tick, a visual representation of the top of the camera. And just from this window alone, you can tell something went wrong. The camera path is broken, the lines are curved, and overall, it doesn't look like what actually happened in the shot. And we know the camera in the shot was moving strictly to the right, smoothly and steadily. This window is a very useful diagnostic tool. It helps you quickly assess how close the tracking and solve results match the actual camera movement in the footage. Controls: left mouse button, rotate, right mouse button, zoom in and zoom out, middle mouse button, pan the scene. You'll see this window after every calculation. If the result looks good, click use this result. If not, click reject. Obviously this result doesn't work for us. The auto tracker isn't really that great. And if we take a look at the 2D trackers, we'll notice quite a few bad points. For example, this point is following the truck. These points are drifting along the pole, and this one is jumping around on the sign. Obviously such trackers need to be deleted. 3DEqualizer does have an automatic tool that tries to detect bad trackers and select them based on certain criteria. But honestly, it works inconsistently. On this particular shot, it's almost useless. I've already tried it. But let's take a look at how it works. In the calc menu, there's an option called Find Badly Tracked Points. As the name suggests, it looks for poorly tracked points. There are shots where this tool is genuinely helpful, and others where it doesn't work at all. Let's take a look. Everything with the prefix auto either works or doesn't. Naturally, a solid track shouldn't rely on randomness, but we'll go through it anyway. Which points should we scan for bad tracking? We'll focus on the points created by auto-tracking in the point browser. These are labeled with the word auto. These are all the points generated by the auto-tracker, not the ones we manually added later. You can also choose to search among manually created trackers, though I don't really see the point, or among all trackers, meaning both automatic and manual. But honestly, if you've manually created a bad tracker, you might want to revisit these lessons from the start. Catching bad manual trackers shouldn't happen at this stage, and absolutely never will. But the setting exists in case someone less experienced handed the project off to you. The result of this pass can be either just highlighting the bad trackers based on what the program detects, or immediately deleting them. But for now, it's safer to just highlight, so we can manually review what's actually being flagged. Sensitivity defines how strict the program is. Higher sensitivity, more trackers will be flagged. Lower sensitivity, fewer. Let's press OK. Now in the point browser and the viewer, you'll see some trackers are highlighted. However, on this particular shot, the program flags not only bad, but also good trackers. So it makes no sense to delete everything blindly. Still, among the selected points, we do see some clear offenders. One tracking along the truck, another jumping on the sign. So to make use of this step, let's now switch to manual tracking controls and start deleting the bad trackers by hand. Use Alt to select multiple points, review where each one is failing, and delete those that clearly don't belong. As soon as we delete most of the bad points, the camera will immediately start solving more accurately. So, it's a bit tricky to identify bad tracking points just by looking at them. Here's what we can do. In the View menu, enable the option Show Tracking Curves. Once that's on, when you select a tracker, you'll see a graph of how it moves over time. If the movement is more or less smooth depending on the nature of the camera motion, the curve should reflect that. But if you hover over a suspicious tracker and its motion curve is messy, erratic or jagged, just like the tracker itself, then you know it's probably a bad one. If that pole weren't in the shot, everything would be much easier. If the truck weren't there, either even better. But I decided not to pick a completely toothless auto-tracking shot, just so we'd at least have some challenge, something to explain along the way. That's actually a good thing. When things don't work on the first try, it immediately pushes us to start looking for solutions. In general, when you're tracking manually, you definitely shouldn't be letting through bad trackers like this. Still, we'll likely get a camera solve, even with a small percentage of poor quality trackers, because when there are a lot of points, the overall weight of the good ones tends to overpower the errors from the bad ones. That doesn't mean, well actually yes it does mean, it's just complicated. Once you've seen enough weird edge cases, it's hard to speak in absolutes, so sorry. But the core idea is this. The higher the percentage of good trackers, the better the final result. If all your trackers are a bit off, like on a really rough shot, then a larger number of slightly bad trackers actually works better than just a few of them, because the errors start to cancel each other out statistically. And by bad trackers, I don't mean the ones we're deleting right now. I mean situations like in night footage, where you physically can't see the exact feature you're trying to track. In cases like that, the 2D tracking itself is imprecise, and you know it's imprecise. Maybe I'll find an example like that to show in the next lessons. So to summarize, even if some trackers are imperfect, if you track many different areas, the solve can still come out accurate because the errors balance each other out. Let's delete this one too. Maybe there's more to clean up, but even after deleting a decent chunk of the worst offenders, the remaining bad trackers won't impact the result nearly as much anymore, simply because they're outnumbered. Sure, we could go frame by frame and find more to remove, but we've already done enough to test the solve again. Let's hit calc all from scratch, and now this starts to look a lot more like the real camera movement. I'm not saying it's 100% accurate, but it's closer, and really, this is the job of a match mover, to get a little closer with every iteration. This actually does resemble the camera path from the shot. Alright, you can press the I key to toggle off the color correction, then switch the viewer to lineup controls mode. We'll go over this mode in more detail later, but for now just know, this is the viewer mode used to evaluate your tracking. We have the same yellow 2D trackers and green crosshairs. The yellow trackers are the 2D points, while the green crosshairs represent the 3D points that appeared as a result of the calculation. Ideally, the yellow point, in our case it's yellow, later there might be red or other colors, should sit exactly in the center of the green crosshair. The worse the alignment, the worse the track, and vice versa. The more accurate the match, the better the track. The green crosshairs are the result of our tracking, and it's important that they match the tracked point. There's also a panel called Deviation Browser that shows the tracking error and an error graph. For example, here we have a maximum error of 5.44 pixels. It's important to emphasize that this is just a tool. Many people tend to get fixated on the Deviation Browser and try to reduce the error down to 1 pixel or less. Yes, that's good, but you shouldn't rely solely on it. It's simply an indicator, a reference, and not an absolute truth. Sometimes Deviation Browser might show a high value, but the track is still considered good, and vice versa. Treat this panel just as an analysis tool. We'll come back to it later. In the Deviation Browser, you can choose to display the error not for the entire track, but for each tracker individually. To do this, go to the Deviation Browser menu and enable Show Point Deviation Curve. There you can select, for selected points, for active current points, for all trackers. In the Deviation Browser, you can choose to display the error not for the entire track, but for each tracker individually. To do this, go to the Deviation Browser menu and enable Show Point Deviation Curve. There you can select, for selected points, for active current points, for all trackers. Why do I keep saying not to rely entirely on the Deviation Browser? Because if you select a tracker in the Deviation Browser that shows a high error, but visually it sits perfectly, that doesn't mean you should delete it. It just means you're misinterpreting the data from the Deviation Browser. Again, the more closely you examine the scene, the more bad trackers you might notice. But we won't get too deep into that right now because there's a high chance that almost all the trackers here are actually bad to some degree. And if we delete a certain critical number of even slightly bad trackers, the whole solution may collapse because the result we're getting is held together by the overall weight of many not completely bad trackers. When their number drops too low, the quality of the track can suddenly drop off, and in some cases, it might not solve at all. We've deleted a few more trackers. Let's recalculate. Alright, we don't like this result. Let's restore a few of the points we previously deleted. In 3DEqualizer, the undo system is quite inconvenient. I'd even say that overall, Ctrl-Z is poorly implemented in the software, so it's best to save frequently and not rely on undo. What's truly inconvenient here is the rollback of changes. Let's calculate. Well, we've got something here. So it sort of sits, but in reality it sits poorly. The green line is the horizon line, and it's jumping around. The calculated 3D crosses, green points, are supposed to sit exactly in the center of the yellow 2D trackers, even in frames where the 2D tracker has already disappeared. For example, here you can clearly see, as soon as the 2D points disappear, the corresponding 3D trackers instantly drift off their positions. And now, it already looks like the sign has shifted out of place. There's clearly still significant lens distortion here. For example, we can see that the pole is heavily curved, but when it's in the center of the frame it appears straighter. That's because this was shot with an anamorphic lens, which introduces complex distortion. We could of course apply some rough minimal distortion correction by eye and recalculate. I just happen to know this shot, and I know exactly why the auto track turned out bad here. For example, I'll increase the number of trackers. I'll double the search area. I'll slightly increase the distance between the trackers. Here you can see that the trackers are now distributed a bit more evenly. The trackers that were drifting on the sign, that happened because the foreground moves very quickly and the program couldn't keep up from frame to frame. This is controlled by the search area size parameter. Hopefully this time the result will be better. Now we're moving on to manual tracking, and there we'll be able to explain the meaning of these parameters more clearly. But just so we don't finish on a bad result, let's clean this up a little bit more. And even without deleting any points, it's already not the worst result. It all comes down to how the 2D track was done, and of course it's always better to do it manually. Well, AutoTrack can still be improved and refined, but that's how it works. Well, it's not as bad as it could have been, but it's clearly visible that the points sitting on the sign are on the background. Yeah, it's not perfect, but that's AutoTrack. Let's manually track this shot in the next lesson and see how much faster and more enjoyable it can be.